Hello grade 8 students, and welcome back to Math with Mr. S. We are beginning our brand new unit on the Pythagorean theorem, and rather than launch straight into it, we need to get some background concepts that will lead us there very nicely. And so today what we're going to do is we're going to figure out how we can use square roots to determine the length of a line on a grid. And we're going to work our way toward a line that looks like this. And the challenge with knowing the length of this line is that it's not following exactly along the grid. If it were following this way, you could fairly easily say it is 6 units long. But you can probably see that this line is a little bit longer than 6 units long, and so its length is not necessarily that easy to determine. And rulers have a limitation in terms of their accuracy of what you can read, and we'd like to be a bit more accurate than that. So to lead up to a line that's diagonal on the grid, I'd like to begin with one that is straight on the grid. This one, you can fairly easily see right away, is 4 units long. But I'd like to suggest a way to get the area for this one that will take longer, but will set us up to get the length for this one. It will set us up to get the length for this one. And that method is to complete the square for this particular line. So now it's 4 units on each side. And we know that the area of a square is its side length times its side length. So that's 4 times 4. And that is 16 units squared. So now I know the area of this square. If I find the square root of that area, I will get 4. And that is precisely the length of the line. So what did we do? We created the square around that line, found its area, took its square root, and that gave us the length of the line. Obviously a procedure you'd never use when you can just look at it directly and see it's 4 units long. But it sets us up now to be able to deal with this one. And the trick here is to build the square on it, find the area of that square, get the square root, and we'll have our side length. So it's a little bit tricky at first to create this original square, but you can see that our line's not going to come down this way. It's going to be diagonal out that way. And I know how far it's going out because I know how far it went up. It went up by 2 and went across by 6. So I'm going to go over by 2 and then down by 1, 2, 3, 4, 5, 6. There's one spot. Then I go down 2 and 1, 2, 3, 4, 5, 6. And there's the other vertex of my square. So I can join these up and I will have built the square with the side length that I'm looking for. So I'd encourage you at home to maybe pause the video and go ahead and replicate what I've done here. It will create a note for yourself, and you'll be much more engaged with it if you're trying to follow along and do the same things. Go ahead and pause it. You can draw this square. Remember, you put a dot on your graph paper, go up by 2 and across by 6, and that's our original line, and then you can build the rest of the square on it. Now the question is, how do we get the area of this square? It's really nothing in it as it stands right now that really makes that possible because we don't know the side length. But the trick lies here. We create something that I call the containing square. What I mean by that is there is a square that lies directly on the grid that precisely contains the square that's kind of hanging out here at a bit of an angle, a little bit rotated, if you will. And you make sure that that containing square exactly touches the vertices of the square we're interested in. And we just about have it here. So there's my containing square. Now if I can get the area of the containing square, and then find the areas of these triangular pieces, how would I use that knowledge to get the area of the square on the inside? Well, you guessed it. We'll take the area of the containing square, we'll subtract the areas of the triangles, and we will have the original square. And note for a moment that each of these triangles is absolutely identical. They all have the same amount of area. They're base length and height are always identical. They're rotated, but same area. Okay, so for the area of the containing square, we will need the side length times the side length. Well, we have 1, 2, 3, 4, 5, 6, 7, 8 as the side length. And so we have an area of 64 units squared. That's for our containing square. Now let's figure out the area of a triangle. We know that the area of a triangle is given by the base times the height divided by 2. Well, the base of this triangle on the bottom is 1, 2, 3, 4, 5, 6 units. The height is 1, 2 units. And then we have to divide that by 2. You can see pretty quickly that that comes out to 6 units squared. Now, there are 4 of these that are identical, so I can say that the area of the triangles will be that 6 multiplied by 4, and that's 24 units squared. All right, so we now know the area of the large containing square. We know the area of the shaded region. How do we get this area? Yes, we take the area of the containing square and we subtract the area of the triangles, and that will give us the area of the original square. So that is the 64 minus the 24, and that is 40 units squared. So our original square has an area of 40 units squared. And now we're in a position to figure out the length of that line. Let's remember what we did here. We got the area of the entire square, found the square root of that. That gave us the length of one side. It's precisely the same thing here. So the length is going to be the square root of the area of 40. Now, this number, as it's reported right here, is really good enough. It's very accurate. If you find the square root of 40 on your calculator, you'll get a decimal answer. The square number closest to this is 36. And so the square root of 36 is 6. This is going to be a little bit bigger, around 6.5 or so. And that defines exactly the length of this line. And we can report that length as just being the square root of 40. If you'd like to put it in a calculator and report some decimal places, I'm fine with that as well. Okay, so I paused things for a moment there just to go ahead and pop this in the calculator. It comes out to this, and then there are more decimal places. But remember, if you want to report the decimal, never just truncate it. Don't just chop it off, but properly round it. So I'm thinking maybe if I want to report to this decimal place, I look after it. That's a 5. That means round up. And so you can say this is approximately equal to 6.325 units. And that is the length of the diagonal line. Feel free to rewind or replay if anything's unclear. Again, I encourage you to try to follow along and draw your own square and containing square and get practice with that. And then don't forget to check in back at Classroom for today's assignment. I wish you the very best with it. Thanks everyone. Have a wonderful day.